So, like I was saying, the single index portfolio is a way that is quite often used by managers out there. So they wouldn't compute the entire covariance matrix in order to arrive at an optimal portfolio, but rather they look at a small subset of stocks that they either really like, in which case they will go long, or really don't like, in which case they can go short. And the process, what you do is they have this thing called the active portfolio. So the active portfolio, and it would have in there 20, 30, 40 stocks that you want, okay? And the first step is to determine how much you should have in that active portfolio. The relative weights, in other words, okay? If you had $100 in the active portfolio, how would you allocate amongst the different stocks? Now that's step number one. Step number two, you are going to plug this active portfolio together into the market portfolio. Okay. Now you go through a second step of trying to determine how much should be in here. I call it X, and how much should be in here, which I call Y. Okay. Now there is actually a last step, which is depending on your risk appetite and the utility function driven formula that we were discussing last time, how much of your total wealth do you want to invest in risky assets, including the market, okay, versus risk-free assets, okay, risk-free. So it could be that you have determined the weights within your active portfolio, and maybe you have 5 stocks, and some of them are 30%, 20%, 45%, whatever, okay? And then you determine that, okay, maybe X should be, let's just say 15%, and Y should be 85, for example, okay? And then you determine the last step is, out of all the money you have, how much do you want to have in the risk-free? Okay, so maybe this can be 30%. So if you had, I like thinking in dollar terms, okay? If you had 100 million, so 30 million should be in the risk-free, then 70 million would be invested in the risky assets, of which 15% would be in your active portfolio and 85% would be in the market. Okay, now I'm giving you a sort of introductory overview, and we're going to come back to all of these steps in just a moment. Okay, now let me just draw your attention to first of all this page here, and we are going to have a look at Bodhi chapter 8, starting question 17. Problem 17 in chapter 8. Now let's just have a look at the part A. Okay, so you've got these 4 stocks, and you have expected returns, and they ask you to calculate the expected excess returns, and the alpha values, and the residual variance. Now, I'm just going to switch over to this page here. Now, first of all, those numbers that you see on the question for the expected returns, these are your expectations. This is what you expect, or your analysts are predicting this stock is going to give me. So for stock A, they predict it will give you 20. If you look at this part here, middle, this is simply the capital asset pricing model formula of RF plus beta I, this one here. Okay, multiplied by the market risk premium. So according to CAPM, you should be getting something like 18.4, but because your analyst or your stock selection specialist is predicting 20, if you were right, okay, then you can look forward to. Of course, you have to assume you will be right. Otherwise, why bother? Okay. So if you were right, then you would be able to look forward to an extra 1.6% of what we call alpha. Okay. So that's what this is. And the expected excess return is just whatever is the return minus the risk-free rate. So minus 8%. And you also have to work out the residual variances. Now the variances are these numbers here on the right hand side. So all you got to do is you just square them. That's the residual variance. Okay. I don't know why they're not using percentages. They're using real actual hard numbers. So you should divide them by 10,000 or 1,000. 10,000. Yeah. Okay. I think that actually there's a risk that it's going to confuse people. Okay. So that's question A. Now, question B is probably by far the more challenging part, and it relates to all the steps that I have written here, which is extracted from the book, the Bodhi textbook. This is what you would do in order to work out how you should invest. Okay. Now, so calculate the optimal risky portfolio. Now, step number one, if you have rub out some of the stuff. So you have stocks A, B, C, and D. Now, the first thing I draw your attention to is this, that in fact, two of them have positive alpha, A and C, and the other two have negative alpha, B and D. Okay. So that's the first thing to keep in mind. What you would end up doing, or what you must end up doing is you should go long stocks A and C, and you should go short B and D. Okay. And so what weights should you really be using? Well, it depends on what is the individual alpha that the stock can bring in relative to the risk that you're running. And that's what this parameter here is. The alpha divided by, or per unit variance, okay? Now you can see that if you divide the individual alphas by the individual variances, which you can find on the previous page, so you divide this number here by this number here, for example, okay? So this is the weight that you end up with, which is here, and you have four different weights. Now there are two things two comments I can make on this. Number one, they don't add up to 1, but that doesn't matter. Okay, reweighing the basket of stuff is precisely about adjusting so they would add up to 1. Now the second point is some of these numbers are actually negative. Okay, but that doesn't matter either. Okay, the objective is you turn them around so that they all add up to 1. And even if some of these are negative, it doesn't really matter. So you all know how you weigh something, right? So you just divide the individual number by the total. That would be the weight. And you can see that the sign actually changes because you are dividing this number here. You're dividing this number here, for example, 000476 by this number, okay, which gives you this number here. So now you have a negative weight for stocks A and stocks C, and I just told you that you need to be long. You should be long A and C, and you should be short B and D. Right? Now you see in a moment it doesn't matter. In the answer they said, do not worry with the negative weights of the positive alpha stocks, which are stocks A and C. Okay, the entire precision will be negative, returning everything to good order. I'll show you in a moment how that's done. Okay, but now for now, for some reason you have negative weights here. Okay, but I'll come back to that. Okay, now whatever these weights are, it means that out of $100, again I like using that. Out of $100, you will actually invest 170 in D. You would go short sell 120 in C. You would invest 112 in B, and you would short sell 61 in A. Everyone is okay with that? Yeah? Yes? We get to that part actually in the next question. When you are adjusting the alpha, adjusting the beta, you do use the information ratio. But here, the way you want to weigh them is, so you say why don't you divide it by sigma instead of sigma squared? These weights will allow you to calculate the alpha of your portfolio, first of all. Okay? And the way you would do that is to use the weights that you have calculated over here, 1, 2, 3, 4. You multiply these by the individual alphas, and you arrive at the alpha of your active portfolio. Notice that the alpha of your active portfolio, when you multiply them out like this, is actually negative. So you've got a negative alpha. Okay. And you can also work out the beta by doing something similar. You can also work out the residual variance, and then you multiply the weights, the square of the weights, together with the variance of the individual components. Okay. Now, once you've done that, what you do, so what I'm saying to you is we've already done, this is the step 1, which we did, identifying the stocks, bless you, and calculating what should be the weights within this portfolio. Now we want to know between X and Y, what should be the proportion of X and Y. That's the second step. Okay, and the way you would do that is, again, to use the alpha variance ratio of your active portfolio, and then compare that to the market excess return divided by the market variance, and then you arrive at a weight. Now here, a couple of things. First of all, this weight that you can see is approximately minus 5%. Where did that come from? Well, first of all, there's a minus 16.9% here. Now this came from this value here that you calculated, okay? And then this alpha, so this sigma square is just this value here is a huge number because they haven't divided it by 10,000. And then this one, 0.08, that's 8%. That is the market excess return. And then the market variance is square of 23. Now this came from where? This came from the first page, right here. Okay, so everything actually has a place, and you work out that the weight that you should invest in this active portfolio is approximately minus 5%. Now, first thing to say is, okay, you have a negative here. That means you actually have to turn everything upside down. And that actually makes sense. The reason is, according to the portfolio, I should be short A, long B, short C, long D. Well, A and C are the ones that are the good stocks, okay? But because the weight is negative, that will turn everything upside down. And I end up actually going long A, short B, long C, and short D. That is what they mean by don't worry with the negative weights, because the entire position will be negative, returning everything to good order. Okay, so that's what that means. And now, this is the weight that you may be using. However, you need to make an adjustment according to what is the beta of your active portfolio. So when you have an active portfolio, whether you invest 15% or 20% or 25%, okay, you can still figure out what the beta is of your portfolio. And to put it simply, you would invest this amount if the beta of your portfolio is actually equal to 1. Okay? And if it is not equal to 1, you need to make a small adjustment, which is given by this formula here. Okay? Now you can see that if beta is that beta of your active portfolio, if it's equal to 1, then W star is actually equal to W naught. Okay, so it's only when the beta of your active portfolio is equal to 1 that W star will be the same as this weight that you have calculated. Otherwise, you need to make an adjustment. Now, people sometimes ask me, what is the rationale behind this? Now, one way to think about it is this. You know that by construction, the beta of your active portfolio is the covariance between your active portfolio and the market divided by market variance. Okay, that's just the formula. Now, if you multiply both sides by sigma m divided by sigma a, if you do that, then you arrive at, and then these two will cancel out with one of the sigma m, and you arrive at this final formula. So beta of your active portfolio multiplied by sigma m divided by sigma a is actually equal to the correlation. Okay, it's equal to the correlation between your portfolio, your active portfolio, and the market portfolio. Okay, so think of that. This is the formula. So beta A times sigma m divided by sigma A is equal to the correlation. Now, what does that mean? That means if you are running an active portfolio, you can have any beta. Beta can be 1, 2, 3, 4, 5, 6, 7, whatever. Okay, and the reason you have the market portfolio in there is to try to help you diversify away your risk. Okay? Now, if your beta is very high, that means it's highly correlated with the market. So your active portfolio already looks like the market portfolio. Then you could argue that I don't need the market portfolio so much. Okay? So that's why when beta goes up, you can see from here, when beta goes up, W star will also go up, okay, because there's a negative sign in front of it. In other words, the higher the beta, the more weight you would invest in the active portfolio. The more it looks like the market portfolio, the less you need the market portfolio, and the more you would invest in the active portfolio. Okay? Now, maybe you think, well, hold on a minute. Am I investing more? Yes, you are investing more because this is a negative number. So it's still going up from minus 0.05 to minus 0.04. So you are increasing your investment because you are less short. Okay? So you come to the conclusion that you are going to be shorting your active portfolio around 4.86%. So that means if you were to look at this diagram, so Y wouldn't be 85, Y would actually be, it's hard to represent, so this is minus 4.86 and Y would be 104. So you are going to be overweight the market, and then you are short selling that active portfolio. Now, how does that work out? And that's what this is over here. Okay. So you would invest, if you had $100 million, you would invest $104 million in the market portfolio, and you would short sell $4.8 million in your active portfolio. Now there are a couple more steps. Now for question B, so I've divided the answer into B1 and B2. In fact, if you look at this page, you can trace back. So this step corresponds to part 1 of question B, and likewise this one. So this is 17B1 also, B1, okay. So step 3 is also involved in question 17B1, and step 4 as well, 17B1. And then when you have to compute the initial portfolio, then we turn to 17B2. So I'm trying to relate to you which steps is being applied to answer which question. Okay. Now, once you've done that, it becomes quite easy for you to calculate what is the additional contribution to the Sharpe ratio of your active portfolio, which is given by this formula here. Your portfolio Sharpe ratio should be the market Sharpe ratio plus whatever alpha is added by your active portfolio divided by the variance of your active portfolio. Now, there was a student who was very observant, and she asked me, okay, this is the Sharpe ratio of your active portfolio, but it doesn't say what are the weights that you should use for your active portfolio. Should it be 20/80 or 30/70, whatever? This parameter seems to be silent on that. Which was a good question. Now the answer is this formula is only applicable if you are using the optimal portfolio, the optimal active portfolio. What do I mean by optimal? Optimal means you go through all these steps, you find out what are the best weights to use. You find out what should be the weight of your optimal portfolio, and then you adjust it in terms of beta, and you come up with this value. It's only when you are using this weight here, okay, that you can calculate the Sharpe ratio. If you are in doubt, in the book by Bodhi, they do tell you about that. And then you can just plug in the numbers. And now for the market, the Sharpe ratio is just the excess return, which is 8% divided by 23 all squared. Where did that come from? Well, if the market gives you 16 and the risk-free rate is 8, then the excess return is 8 and the standard deviation is 23. So that's the Sharpe ratio for the market. And the additional contribution, like I said, is alpha divided by sigma e, and then you square that. So what's alpha? 16.9. Now I know it's a negative number, but when you square it, it becomes positive, okay? And 147.68 also came from here. Yeah. Okay? So everything can be accounted for. And the end result is that hold on a second. The market Sharpe ratio is 0.3478, but the one with your active portfolio is now 0.3662. Okay? So the Sharpe ratio has improved a little bit. Yes. Yes.
Question, because you said that it's only possible to use this formula for optimal portfolio, but if this alpha square divided by
sigma square,
it's when I just calculate the alpha for a portfolio before, then I have already weighted alpha, and then I can use it as well. Or I mean, it's already weighted. So if I do it like this always, then I can use it as well.
Yeah, I think your question was precisely the question that the other student was asking. Now, there are a lot of weights going around. Okay, first of all, her question was, okay, when I'm just looking at the active portfolio by itself, there are weights within this portfolio, and when I look at the Sharpe ratio of, let me use a different color. When I look at the Sharpe ratio of this one here, okay, so that's what I'm now calculating, the Sharpe ratio of this portfolio. The question asked to me was, it doesn't look like that Sharpe ratio takes into account X versus Y, whether X should be 30, 70, or 2080, it doesn't look like it's mentioned there. That's what you're saying, right? Well, it does. It does because you would use this formula here if and only if the active portfolio is invested in the optimal way. Now, what I mean by that is it has to be invested with these weights. This one.
Can't you use other weights?
If you use other weights, then this formula is not valid.
But why, when you just use this as a weighted part, then you can use it. Doesn't matter if it's optimal or not optimal. It just depends on the weights you decided before. It can be different.
No, there are two optimizations going on here. Okay, first one is when you are just working on the active portfolio itself. Okay, so you have okay, 10%, 20%, 50%. So you optimize the weight within this one. Okay. Now the second optimization is when you have a combination of your active and the market. So this might be 90-10 or 80-20. In this case, it's actually 104 minus 4. Okay. Once you have done that step, and there's only one unique combination. Okay. Once you have done that step, then you can claim to have an optimal portfolio. And this alpha here specifically refers to that combination. Yeah. Are you with me?
Yeah.
Yeah. Okay. I'd like to all right. Now, just to go into a little more detail, I answered exactly that question last night, and I'm going to share with you. So they were asking, how come in determining that Sharpe ratio, you don't need to have the weight of the active portfolio versus the weight of the market portfolio? How come it doesn't show up? Well, my answer was, it's not that the Sharpe ratio of your combined improved portfolio is not that it has no relation. It has a relation, okay? That Sharpe ratio equation for the new improved portfolio is applicable if and only if your portfolio consists of the market portfolio and an active portfolio that has optimized weights. That's my point. Okay? With the adjustments as I described last time. And in fact, if you were to look at Bodhi, edition 10, so on page 275, they tell you exactly that. Okay? So let me enlarge that a little bit. So equation 8.22, the one above, okay, shows that the contribution of the active portfolio when held in its optimal weight, WA, that's the most important point, in brackets, okay, when held in the most optimal weight to the Sharpe ratio of the overall risky portfolio is determined by the ratio with alpha to its residual standard deviation. Okay, this one is called the information ratio. So it's only when you are investing with the optimally adjusted beta that this applies. Okay. Now, let me switch over. Now, this is actually for part D, 17D. This is now the third step, if you like, of the optimization. Now, step one is you just figure out what you want to do within your active portfolio. So step two is when you combine the active portfolio with a market portfolio, what would you do? Is it 20/80, 30/70, whatever? Step 3 is according to your different risk appetite. If you had $100, how much do you want to put in cash and how much do you want to put in this combination? Okay, so it's optimization and reweighting here, optimization, reweighting here, optimization and reweighting here. Okay, so the last step actually is the easiest. To work that out, you just take that quadratic utility formula from last time, where you can work out the Y value. Y value is what you would invest in risky assets. Okay? So you work out, if you were given a risk aversion parameter of 2.8, that you would end up investing, you would invest around 57% in risky assets and 43% in risk-free assets, treasury bills. So of that 57%, you're going to overweight on the market 105%, and you're going to short sell the active portfolio. Okay? So once you do that, stock A previously had a negative weight. Because you are short selling, you turn everything upside down. Now you buy A, you short B, you long C, and you short D. And everything adds up to 100. Okay? So that would be the final step for doing that.
Excuse me?
So for question 17D, is asking you if somebody has a risk aversion coefficient of 2.8, how should they actually be investing? Okay, and in order to determine that, you have to think back at that utility function where you can work out the Y value. Given the risk aversion and the formula, and we discussed this actually in the last tutorial, as you recall. Okay, and then you determine that you actually should invest around 56% in risky assets, and around 43% in risk-free asset, and that's what you end up doing. Okay, so imagine always, my favorite way of thinking is, imagine you had $100 or $100 million. Okay, so you have $100, around $43 will go into your risk-free assets, and then the other part, you are going to overinvest by investing 56%, leveraging up 4.8%. So you're going to invest $59.60 in the market portfolio, and then these weights accordingly. So when you add them all up, they would be equal to 100. Okay? So this is the last step. This is actually including a risk aversion parameter, and which means you would have to allocate your money between cash and the market and your active portfolio. So previously we were just doing this part, but it's still, everything's still get properly scaled. Okay? I'm running out of time a little bit. Now, let me look at, now, problem 18 actually is an interesting one. It is similar to problem 17, with the exception that you are not allowed to short sell, okay? And so they're asking you what happens to the Sharpe ratio of your new portfolio if you cannot short sell, and what is the loss of utility given a new portfolio. Okay. Now this time you actually can reuse or recycle some of the numbers before, but if you can't short sell, you are left with stocks A and C only, because if you look back, if you recall, on this page, or the page before, so stocks B and D actually have negative alpha. So you would quite likely want to look at short selling it. So I'm telling you what, you can't do that. If you are running a mutual fund, the real traditional, classic CFA type platform, a lot of funds do not allow you to short sell. So this is a real problem facing them. So if you're not allowed to short sell, forget about B and D, okay? But you can still try to get involved with stocks A and C, which is what they end up doing here, okay? So you just have two stocks. You go through the same process. So you calculate the alpha, and the variance, and the weights. Now here, this time we don't have negatives. The weights, the initial weights are just the alpha divided by the variance, and then you can reweight them. Now here, this becomes a lot simpler. Okay? Maybe if this question was the first question, it becomes easier to understand. And then you have the weights, and then you do the adjustments for the beta. So you calculate what the beta is. It's close to 1. Okay, so your adjustment will be very little. So the original weight was 9.4%, and it becomes readjusted to 9.31. And when you try to work out the Sharpe ratio, again using the same formula, alpha that you are adding divided by the standard deviation, the residual, and then you square that, and this is how much you are contributing to the Sharpe ratio. Okay. Now notice the market Sharpe ratio is 0.3478. When you were allowed to short sell, you can pump it up to 3662. That's the one we calculated last time. But if you're not allowed to short sell, your Sharpe ratio is improving, but it's kind of somewhere in between. Okay? So I think this is a very strong argument actually for allowing people to short sell, because they can manage their portfolios, in a more optimal way. Okay. And then you can calculate the weights as before. You calculate the Y value. Okay. This time there's no short selling, so it's quite straightforward. So this question is actually easier than the last one. Now, for you to work out what the utility is, you just use that same quadratic formula, and you just plug in the expected value for your portfolio, which is the risk-free rate, plus whatever you are invested in your risky portfolio, minus half A sigma C squared. Okay. So I'll leave you to figure that out. Now, let me take a look at chapter 9. Now these problems are quite simple. Now, further to the tutorial discussions, there are
a couple of questions that were asked to me, and allow me to address them here. The first question was regarding when you are using the single index model and you need to determine, and you have a number of stocks, A, B, C, D. So this was the question. And you are trying to determine with your active portfolio just what the initial weights should be, A, B, C, D. I mentioned that the weights should be a function of what alpha these stocks are bringing to the portfolio, divided by the variance that these stocks are bringing to the portfolio. And there was a question asked by someone in the tutorial 3, why are we using the variance here? Why not just divide the alpha by the standard deviation, which is what you do for Sharpe ratios? Okay, that's a good question. Now, you are trying to weight these A, B, C, D to determine what proportion you should be investing in each of these, and the weights, or what you end up using as your weights, have to be capable of a kind of linear proportional relationships. What I mean by that is, if you have stock A with alpha, certain amount of alpha, and stock B has another amount of alpha, now for them together, the total alpha would be just the alpha A plus alpha B. Okay, now this is called additive, ADDITIVE. Okay, you can linearly just combine them together. Okay, that is why it is possible to use alpha as the numerator for the weight. Now, for the denominator, why is it that we use sigma square instead of sigma? Okay, so additive, a substance added to something in small quantity in order to improve. Additive in mathematics means they can be added together, and I'll show you shortly something that is not additive. Okay, so why is it that we are using sigma square? Well, precisely for that reason. Okay, that they are variances has a statistical convenience that they are additive. So here you have 4 stocks with a whole load of residual standard deviation. So this is residual sigma. Now, you might remember that from the notes of Professor Fong, when you are using the index model, the overall portfolio variance, okay, would be the portfolio beta square times the market variance plus the overall portfolio residual variance, which in turn can be broken down into, if they are equally weighted, okay, then the weights multiplied by the individual variances. Now, you take a look at this term here, and you can see immediately that variances can be linearly summed together, but standard deviation cannot. Okay, that is why it is actually technically possible to use variances as your weights, because they are linearly connected, whereas standard deviations are not. If you take that to the extreme case, or a really simple case, such as just 2 assets, for example, asset A and asset B. So let's say they are equal weights, 50-50, and so asset A has standard deviation sigma A, and asset B has standard deviation sigma B. Now, if they were well diversified, first of all, the portfolio variance would be this equation here, which I'm sure you are very familiar with. Okay. Now, if the risks are actually, if the asset volatilities are well diversified, so as the correlation tends to 0, okay, the portfolio variance really becomes just WA squared sigma A squared plus WB squared sigma B squared. And because WA and WB are the same, you can take that out. And what I'm trying to demonstrate here is that portfolio variance in this case really can be the sum of two individual variances plus multiplied by a constant, but never mind this one here. Okay, so there is a linear relationship going on here, which is why you can use them as weights. Okay, which you cannot do. You take the square root of this, and on the other side it becomes a complete mess. Okay, that's the reason. Now, the second question, which I thought also was a good one, was regarding this question here. And when you have two stocks, one of them had a lower return and a higher standard deviation. So clearly, all things being equal, stock X would have a poorer Sharpe ratio compared to stock Y. And we're asking, if you were to add this stock to a well-diversified portfolio, which one are you going to choose? And if you were to just hold, if I force you to pick stocks X or Y, which one will you choose? Okay. And the answer was, if you were going to add it to a portfolio which is well diversified, you should pick something with positive alpha. And somebody, and then if you were to just pick the stock, then you should pick something which gives you a good return per unit risk taken. Then when you have the same risk, one stock will give you a higher return, and you are not diversified anyway. Okay, if you just have a single stock, so you should just get the maximum return with the same risk, or same return with a lower risk. Okay, now that should be obvious, but for part one, so why is it that you do not pick the stock with a higher Sharpe ratio? Why do you pick the stock with a higher alpha? Okay, now a clue for answer of that question possibly can be you can be taken here when we start talking about this formula that I was writing during the tutorial, that when you are adding some stocks to a well-diversified portfolio, if there is any improvement to the Sharpe ratio, it would be represented, once you have the optimal weights, it's represented by the pre-existing Sharpe ratio for the market portfolio plus whatever alpha you are adding, divided by the volatility. Now, so if you have two stocks, and just look at this equation here. Okay, so if all you know are their Sharpe ratios, they can have very high Sharpe ratios. Okay, but if they are just fairly priced, you know the alpha could be 0 or maybe even negative, which is precisely the question being put to you. Okay, in this case, as you recall, only one stock actually has a positive alpha. Okay, So that is the one. That is why that's the one you should be adding. Now you might be wondering, oh, hold on a second. Well, the other one has a negative alpha, but once you square it, wouldn't you also be adding? Then it becomes a positive number, and you would improve on the Sharpe ratio. Yes, you would. But if you were to add a stock to your portfolio with a negative alpha in this context, once you optimize it, you're going to find that you will actually be short selling it, just as we demonstrated earlier this morning. Okay, so because the other one had a negative alpha, you definitely don't want to use it. That is the reason. Okay, even if you are improving the Sharpe ratio, you would not be buying this stock in order to do so.